in our book they'll be looking at classifying conic sections using the discriminant. We have done that just by looking at the coefficients of x squared and y squared. And the only time that using our method is a problem is when we have this b times x times y term. And what happens with that is it takes the conic and rotates it. So instead of having a parabola that looks like this, you have maybe a parabola like this, where here would be the axis of symmetry. And we're not going to deal with those, so we're just going to ignore this part here and stick with our chart of looking at just the coefficients of the x squared and y squared. So the only thing different on that we haven't used so far is when the x squared and y squared have different signs, and therefore we have a parabola. So we want to use the discriminant to identify the conic section for this equation. We see that 4x squared and 4y squared, we have the same coefficient with the same sign. So that tells us that this is going to be a circle. And let's go ahead and complete the square to write the equation of this circle. So we have 4x squared minus 4x plus 4y equals 8. And if we take that and set it up for completing the square, and that 4y was a 4y squared, so we have 4 times the quantity x squared minus x plus something plus 4y squared equals 8 plus 4 times something. And our something here is 1/2 of 1, so it's 1/2 squared, and 1/2 squared is 1/4. So we have 4 times the quantity, x minus 1/2 squared plus 4y equals 9. And if we take that then and divide by the 4s, we have x minus 1/2 squared plus y equals 9/4. So from that we see the center of the circle is hk equals 1/2 0. And the radius of the circle is the square root of 9/4, or 3